Welcome to the first of a series of videos intended to help you effectively incorporate the AVS Science Educator Workshop Vacuum Kit into your high school science curriculum. In this video, we'll explain how to unpack, inspect, and begin to assemble the vacuum demonstration kit when it arrives at your high school. As shown here, the kit will arrive in two different boxes from two different companies. One company supplies the vacuum pump and the vacuum pump fluid or oil, and the other company supplies the vacuum base plate, related vacuum fittings, and plastic bell jar, and a vacuum pressure indicator. As usual, the first thing to do is make sure that all the required parts are present and appear to be undamaged. If any of the parts are missing or damaged, it's suggested that you call the respective company and describe the issue. The first box is from Richie Engineering Company of Bloomington, Minnesota. This box will include two main components. The first is a 1-quart container of Yellow Jacket Super Evac Premium Vacuum Pump Oil that is shipped in a sealed container. This container will be nested near the top of the box when you open it. The second component is the vacuum pump itself, which is known as the Yellow Jacket. This box also contains an operation and instruction manual for the pump. This manual is written primarily for technicians working in the refrigeration industry, and so much of the discussion relates to that use. However, the manual is well written and contains a lot of useful information on operation and maintenance of the pump, as well as some tips on basic troubleshooting. The discussion in the manual also includes descriptions of optimum refrigeration maintenance procedures that may actually be useful in preparing related classroom content. The bottom line is, you may want to scan a copy of this reference manual for future use. Finally, the box contains a red tag that has 3 important statements. The first statement indicates that the pump should not be used to recover or transfer refrigerants. Although this statement may seem unexpected because you've been told in the AVS workshop that the pump is used primarily for maintenance of refrigeration systems. However, the fact is, this pump is not used for the specific process of removing or transferring refrigerant. That process is done using a different system called a refrigerant recovery system. This Yellow Jacket pump is used once the refrigerant has been removed to clean the refrigerant lines of residual water or other vapors. The second statement on the red side of the card indicates to turn the pump on and off with the intake open to atmosphere. The reason for this will be discussed later in the video. Finally, the third statement is on the white side of the card. This statement indicates that the pump is shipped without oil and that the pump should not be overfilled with oil. The process of correctly filling the pump with the oil will be discussed later in this video. The second box is from Eastern Scientific of Hanover, Massachusetts. It will contain 5 separate components. The first is a Nalgene bell jar that will become the top portion of the vacuum system. The material Nalgene is a polycarbonate-based plastic that will be much safer to use in the classroom than the glass bell jars that would have been used historically. Specifically, Nalgene is safer because it's much less likely to implode when it's under vacuum. The implosion process is very dangerous because it can produce projectiles that can cause serious injury. This was a major concern historically when using a glass bell jar in demonstrations. Although the polycarbonate material is much safer, as noted on the label of the polycarbonate bell jar, the possibility of implosion still exists, especially after the bell jar has been handled for many years in an active classroom environment. This is because handling will almost certainly produce scratches on the outside of the bell jar, and these scratches will weaken the bell jar's overall mechanical integrity. Actually, avoiding scratches is one of the reasons the sides of the bell jar were protected with bubble wrap during shipping, while the bottom of the bell jar was protected with the rubber gasket. Bottom line, it may be worthwhile to save the bubble wrap for later storage of the bell jar. Also, and as will be shown later, to limit the chance of injury while using the vacuum kit, and as was done in the AVS workshop, everyone doing or observing the vacuum kit experiments should wear safety glasses. To bring home the point of the significant force created by atmospheric pressure on the vacuum chamber, one question that could be asked in the classroom is, how much force will atmospheric pressure exert on this bell jar during an evacuation? Well, the bell jar is about 9 inches tall and about 7 inches in diameter, so the surface area of the bell jar is about 240 square inches. If atmospheric pressure at sea level is about 15 pounds per square inch, that means that there will be about 3,600 pounds of atmospheric pressure pushing on the bell jar when it's evacuated. So indeed, about the total force of the combined weight of two small cars if they were uniformly pushing on the bell jar. This short example not only indicates why the bell jar has to be constructed and maintained well, but also may get the students in the classroom to take seriously the reason to wear safety glasses during the evacuation experiments. Getting back to the items in the box. Items 2 and 3 will be two different base plates. One is made of plastic and can be considered for certain experiments if the proper hose and vacuum connections are available in the classroom. However, use of this plastic base plate with the provided vacuum pump will require both a vacuum hose and a special pump flange with a barb fitting, and this flange is not provided with this kit. The more important of the two base plates in the kit is the pre-assembled aluminum base plate that is designed to be mounted directly onto the vacuum pump. This aluminum base plate is configured with a vacuum gauge and necessary fittings to allow for mounting directly onto the Richie vacuum pump. Along with the pre-assembled aluminum base plate is a rubber gasket. The gasket can be used with either the aluminum or the plastic base plate and is used to form a seal between the Nalgene bell jar and the base plate. The fifth and final item in the box will be a small tube of thread sealing compound. The purpose of the thread sealing compound will be for potential use in attaching the new intake flange to the vacuum pump. The potential use of this thread sealing compound will be discussed later in this video series. Once we've confirmed that all the parts are present, the next step is to fill the pump with vacuum pump oil and test the pump for proper operations. To fill the pump with oil, first inspect the drain plug to make sure the drain plug has an O-ring installed and that the plug is properly hand tightened. Next, remove the exhaust cap shipping cover and save it for later pump storage. Finally, unscrew the exhaust port cap. Note that the thread on the exhaust port cap is the same as a standard garden hose. The use of a garden hose to exhaust the pump will be discussed in a later video. 1 quart of Super Evac pump oil is supplied with the pump. The oil is a distilled mineral oil, and its chemistry is very similar to that would be used in your car's engine. However, the vacuum pump version of this oil is distilled further to reduce the vapor pressure to about 10 millitorr at room temperature. Although unused vacuum pump oil is not considered hazardous to contact with your skin, as we all know, oil is messy stuff. Additionally, you may want to avoid contamination of the vacuum pump oil with your natural skin oils. For all these reasons, it's advisable to wear protective gloves when filling or draining the pump. Although the oil can be directly poured into the exhaust port, if you're careful, a small funnel can help avoid spills. When first delivered, the pump will generally require a full quart of oil to bring the fluid up to the proper level. As indicated on the red tag included with the pump, the oil should not be overfilled, as this can cause excessive spitting of oil out of the exhaust port. Also, on subsequent filling after draining old oil, slightly less new oil will probably be required because the inside components are already coated with oil. When the oil is to the fill line, remove the funnel and screw back the exhaust cap. The exhaust cap has a filter screen incorporated to limit the possibility of ejecting liquid pump oil while still allowing pumped gases to escape from the pump. However, when starting the pump, do not look into the exhaust port because there remains a possibility that debris or liquid could be ejected. Once the pump is properly filled with oil, the pump should be tested for proper operation. This is done by first checking that the nameplate voltage on the motor matches the building power, usually that's 115 volts in the United States, and that the switch is turned off. Next, position the pump on a stable area and plug the power into a receptacle. When starting the pump for the first time, the instructions provided indicate to place the blank-off valve into its open or vertical position and to unscrew the cap of the as-delivered flare fitting. Opening the input valve to atmosphere can help the pump start turning, especially if the pump is being started in a very cold environment. This is because during storage, oil will tend to enter the internal volume of the pump. The problem is, unlike a gas like air, pump oil is incompressible. Therefore, during the first few revolutions of the pump mechanism, this oil has to be ejected from the internal volumes through what's called a one-way check valve. This requires extra torque to be supplied by the electric motor, and having the pump open to atmosphere, in effect, limits the torque that the motor has to produce during its first few revolutions of the pump. Next, make sure that the vent valve fitting is tight. Next, turn on the pump and let it run for a few seconds to confirm proper rotation. After a few seconds, turn the blank off valve to its closed or horizontal position. One can also blank off the input by reattaching the cap on the flare fitting. Regardless of how the intake is sealed to atmosphere, in 2 to 5 seconds, the vacuum indicator on the pump should show a pressure near the green region of the gauge. Because the vacuum gauge on this pump is calibrated to atmospheric pressure near sea level, how close the gauge indication actually approaches the green region will depend on the altitude where the pump is operating. In other words, the closer to sea level you are, the closer the gauge dial will approach or enter the green region. Because this particular video is being produced near Denver, Colorado, known as the Mile High City, atmospheric pressure is significantly lower than at sea level. Therefore, even though the pump is operating properly, the gauge does not enter the green region. Once you have assured the pump is operating properly, you can turn the pump off. If the blank off valve is left in its closed or horizontal position, the pump's pressure indicator should continue to indicate vacuum, even when the motor isn't running. However, this configuration presents a problem if the pump is left off for many hours, days, or weeks. That's because atmospheric pressure will slowly push on the pump oil from the exhaust side of the pump and push the oil more into the evacuated inner volumes of the pump. This can make the pump more difficult to start next time. To avoid this problem, it's recommended that if the pump will not be used for many hours or days, the blank off valve should be opened before you turn the pump off. This pre-shutoff configuration will equalize pressure within the inner volumes of the pump and therefore limit the extent to which those volumes will become filled with oil. Pressurizing the inner regions of the pump will also be indicated on the pump's pressure gauge, which should show an indication near atmospheric pressure. With the Yellow Jacket vacuum pump now tested for proper operation, the next video in this series will explain how to replace the flange delivered with your vacuum pump with the flange needed to attach the aluminum base plate to your kit. Thanks for watching.